Hey everybody, thanks for joining another month of our ClearCalcs Learn Hour, ClearCalcs webinars. As always, what we'll do is wait a couple more minutes just in case anybody is running a bit late, working on deadlines, grabbing a coffee, anything like that. And then as always, if you guys want, feel free to use the chat tab, send through your name, your title, the types of projects you work on, again, as always, just to expand our ClearCalcs community, and hopefully maybe you can meet somebody in the area that works on the same type of stuff. And then we'll give this another minute or so before we kick off how to build a house in ClearCalcs. Looks like we got about 45, 46. That number's going up constantly. Great to see. Then thanks for sending through Albert, George, Shelly. Great to see all you guys. Shelly, I think I was emailing Michael. I actually just bought a house in Colorado Springs, so I'm just down the street from you, actually. All right. I think we gave people enough time here. They could come in at the end. And as always, we are recording these. I'll show you guys maybe at the end how you can access past recordings to listen to Laurent's teachings on ClearCalcs. So we'll get going here. Like I mentioned, today we're going to focus on how to build a house in ClearCalcs. Laurent will have a slide where he's going to talk through what we're actually going to be going through, but really we're going to be looking kind of start to finish, going from the plans into ClearCalcs, into exporting, and hopefully show you guys some power-ups and tips along the way. So most of you in this call, I know, have either tried ClearCalcs in the past or are current members of the ClearCalcs community. So very quickly about clearcalcs.com, cloud-based platform, looking to help you guys create more accurate designs, eliminate wasted time, and available everywhere, whether you're at a coffee shop, whether you're camping, whether you're at the office on site, you could access your files. And then who will be really the star of the show today will be Laurent. Most of you guys have chatted with him, North American engineering content lead. So most of the calculators you guys are working on here in the States and then in Canada as well, Laurent has kind of spearheaded those. And then myself, I know I've chatted with a lot of you. I'm our Director of Customer Success, Connor here, running demos, running training sessions. Anytime you guys have questions, reach out here to make sure you're successful in ClearCalcs. And then last thing here, we've added this slide recently just to make sure you guys are aware of this, whether it be throughout the webinar or at the end when we have our Q&A section. Follow the instructions here that you guys are seeing on the screen. Send through any questions in the questions/chat tab, and we'll try to handle those. We'll kind of go first come, first serve basis. If I can interrupt Laurent in the middle of his presentation, if it's relevant to the slide we're on, I'll try to ask. If not, we'll save it till the end to the Q&A session. And then handing over to you, Laurent, take it away.
All right, well, hey, good morning, good afternoon, good lunch hour, wherever you're joining us from. Thank you for joining us again for another webinar. Today we're going to be really talking about basically a project from start to finish in ClearCalcs. We're going to think about things like the actual project setup, how we might share it, the loads, the members we want to design, that kind of stuff. We're going to try something new today, I think. If you've done this before, you've seen typically we'll present something and we'll do the example at the end. I think today we're going to try kind of going back and forth. Let us know how it goes, and I'll apologize in advance if there's any kind of hiccups. First time doing it, but we'll see how it goes. So let's jump right into it. First thing we're going to discuss here is just projects in ClearCalcs. Now, I imagine most of you, if you've used ClearCalcs before, you've probably created a project. That's usually where we'll start with our calculations, things like that. One thing to note here is you always have the option to see everybody's project in your organization. So if you're working in a team and you want to help out a coworker with a project or something like that, that little checkbox here where it says show only my projects, if you untick that, you'll be able to see every project in your organization. You can search for them as well. You can also search for your coworker's name and it'll pop up their project. Really good way to kind of share and collaborate as a team. Cool thing that we've seen quite a few users do more and more is creating template projects. So if you're very often designing the same kind of house, or perhaps you're doing typical retrofits on the same building all the time, you might want to set a project, and you can call it a template or whatever you want to call it. Create your individual calculators in that project, link them as you want. We'll go over how we do that later on. And then when you want to take that project and use it for a real building or something like that, you just create a copy of that template and you'll be able to use it. So it saves you some time there. Next thing here are the project details. So that's the first page you see when you create your project. Important thing to note here, everything's optional. So if you don't have a project number for whatever reason, all good, don't put it in. Cool thing here, I think most of you will be from the US today, but if you're ever doing projects in Canada or you do something in Australia, why not? You have access to all of ClearCalc's calculations. So you can just change the building standard for your project, and then you'll see the Australian calculations, for instance, and you'll be able to design per the Australian standards. Lastly, the other thing you'll see in the project details are preferred sections. And these are a really cool feature. They save you time in a bunch of different ways. One is going to be in finding different sections when you're doing design, but also if you want to use our auto size feature. And just like projects, you can copy them as well from other projects. Just so if you're always kind of using the same numbers, then you can just copy that from a different project and be able to use those sections without manually entering them again. So we're going to jump into an example right away now. This is an old drawing I think we found on the internet of a lightkeeper's house somewhere in California. And we'll see here the lightkeeper's dwelling, Cape Mendocino in California. I hope I'm saying that right. So let's go in ClearCalcs now, and we're just going to set up a project for this lightkeeper's dwelling just on ClearCalcs. So I'm going to switch now. Whoops. Where is it? Here we go. So we'll call it lightkeeper's dwelling. Project number, we'll say 001. We'll call it that. Client name might be Mr. Lightkeeper. And the project date, you'll see by default, it goes to today's date. It doesn't have to be. You could put in whatever date you want. Say this project was actually done in 1930s, and you might say 1930, and that would be fine. Or if you want to put the build date, you could also say maybe it's going to be exactly a year from now. You could put 2023. You've also got a little calendar here if that's useful. For now, we'll just leave it as today. But like I said, it really depends on how you as a company or as a team decide to create these projects or to date these projects. But next, we've got on the right our location information. So project address, we can just type, say, Cape Mendo. We'll get to this one, and that's the street called Cape Mendocino. That's good enough. It's just an example. But you can see, we'll show you a little picture here of a town here. And if I just zoom out a little bit, I can kind of see the location. I can see the terrain around it. So in this case, it looks like we are near somewhere in California, near Los Angeles. I'm doubting that there's a lighthouse here, but you get what I mean. And then we'll set our building standard. By default, if you're in the US, this will probably be United States and pounds already, so you don't necessarily need to worry about that, but it's good to have a double check. We're also going to set our preferred sections now. So I'm going to scroll down here and click Add Sections. And you'll see we've got our wood calculator. It's just going to load. And since we're in California, we're going to select here Douglas fir larch species, and we're going to focus on dimensional lumber. And let's just go with grade number 1 for now. So we'll pick, say, a 2x3, 2x4, 2x6, 2x8, 2x10, 2x12. And We'll call it that. And then maybe we also want, if we're designing some longer spans, we want some LDLs. So we can do that. And let's go here with a microlam LDL. And we'll do, say, just picking a couple different sizes. Okay, so we've got a couple LVLs and we've got our Douglas fir dimensional lumber. So let's hit done here. And so now we've set up our project, so we're ready to get started. What I'm going to do now is I'm going to jump back into our presentation and we'll look at the next steps together. So next is the project defaults. So you'll see this on the left here. These are quite useful in terms of basically setting up the geometry of your project as well as your loads. Important thing here is everything can be overridden. So you can set say the default floor height or railing height or something, and then by default some templates are going to use this, but you can always overwrite these so that you're actually using whatever's appropriate for that specific conditions. The goal here really is to save you some time. So if you're designing a lot of stud walls, for instance, and they're always at the same height, then you can set a default height, so you're not going to have to change that every time. Cool thing here is we've got this project default formula here, and what that does is you'll see we've got a formula reference. You can just type project default, and actually I apologize, there's a typo here, but there shouldn't be an S here. Sorry, you're gonna watch me do this right now, just so we have it. Okay, so we're gonna have this project default and the formula reference, so you can actually use this to access your project default from any template that you want in ClearCalcs. So next up in the project defaults is also your default loads. So this gets really interesting because these are the loads that get passed as you create your calculations. So if you're setting your floor joists, for instance, we're automatically going to use the default floor load. If you're doing a rafter, we'll use the default snow load, wind load, light load for the roof, some things like that. And you'll see we've got drop downs as well, where we basically took the code specified loads, and then we just let you kind of select them, and then we'll automatically update based on the code. Or you can set it in the tables, but usually you'll want to do one or the other. Something that we hear sometimes is you'll have some custom load combinations or something like that. One thing that you can do, you can set these directly in ClearCalcs. So you can choose custom load combinations, and then you'll be able to set kind of the different factors for different load types. You'll also be able to say the strength combination. So if you're checking for strength, you can override your duration factor for wood, things like that. The last thing here is for wind loads. We have a very convenient, I think, wind load calculator. You'll see at the end, you get a nice little graph like this showing for the different wind area, what's your wind pressure in PSF. So you can take that and put it in your project defaults, and it's going to make your life a lot easier. And a cool tool here is the ASCE hazards tool. I'm not sure if any of you have used it before. We find it quite useful just for looking around at things. I'm going to open it just really quick just to show you. So it's available for free on the internet, and you just basically enter an address, say Cape Mendocino, and then you can pick, say, I want wind. Oops. Wind, the risk category typically will be 2 for, say, residential dwellings. And maybe we want snow load as well. View results. And I've got, say, my wind speed and my snow load here. Now, jumping back now here, let's go and enter our project defaults for this lighthouse dwelling. So I've got a few things here, right? I can see my roof pitch is 8 and 12, floor height is 10 feet, and then I've also got some load specified. So snow load is 40 PSF, wind speed is 100 miles per hour, light load is 40 PSF, roof load is 20 PSF. So let's go to ClearCalcs now. Oops. And go to the project defaults here. So the first thing we said, so when we come in here, there's a lot of inputs here. For now, we're going to leave most of these alone. Important things to note here, if you're using a different building code, you can look at that here. For instance, we've got the California building code. Important thing to note with California, there's quite a few amendments with the concrete provisions, so we don't quite support concrete just yet in ClearCalcs, but you can see we've got different editions of both the IBC and the IRC on here. Then you can also choose different parameters for deflections, depending on what your ceiling type is, what type of finishes you have. And then if I zoom in a little bit here, you can see we've got the roof, ceiling, and then that's kind of your L over 360, L over 240. So if you wanted to say override these values, this is where you'd be able to do that. So maybe you've got a high-end customer, they want L over 600 for their floors or something. This is where you'd be able to put that, and that would be used automatically for all your floor calculations. We've also got a few things here for absolute deflection limits. So right now we've got it at 1 inch, but depending on project, again on customers, this might be different. But yes, let's keep going now. In terms of building geometry, we've got our number of stories here, and then we've also got our roof slope. So we said this was 8 and 12, we'll change that. And then we've got our default spacing. So we've got rafter, joist, stud spacing. In this case, let's leave them all at 16 inches. That's pretty typical, but if say you wanted to try 24 inches, it'd be no problem. Thing to note here, if I type in 24, it'll update for all of these. So then you might want to, just for convenience, but you might want to change these later on as well. Next, we've got our floor dimensions. There's quite a few inputs here. The biggest thing I'll say is the important one is the story height here. If I type 10, for instance, you'll see that it updates for the top and the lower floors. So in most cases, you're probably going to be okay just entering stuff in the top floor dimensions. Then we ask you the headroom. So this is, you'll see we've got limits on roof beam depth limits and floor beam depth limits. These are used, especially when we're dealing with auto size, but for now, we're just going to leave them at 0 inches. And then we've also got the window height here. And all that's there for is when we're designing headers, it'll use that window height to calculate the weight of the wall above the window. So now we're going to jump on the right here. And the first thing we have is our default roof loads. So I can see here, I've got quite a few different, options of roof loads. So these all come from ASCE 7. In this case, ordinary flat, pitched, and curved roofs. That's exactly what we have. So we're just going to leave it as is. So we can see we've got a 15 PSF dead load, 20 PSF roof live load. One thing here, we're going to add a 300-pound minimum alternative live load, just because it's a roof, and so we want to have that alternative live load. Some code requires that. Snow load, I think we said was 40 PSF. It's a little high for California, but that's all good. We're not too worried. And finally, we've got our wind loads here. And so what we're going to want to do is let's jump really quickly into our load calculator for wind. I'm going to create a new calculation and choose wind loads, components, and cladding. And now that I've got this, if I look at my ASCE hazard tool, I can see my wind speed here is 92 miles per hour. I'm going to type that, 92 miles per hour. Since we're on the side of the ocean, because it's a lighthouse we're imagining, we're going to have exposure class D. Next, we've got the effective wind areas. The short story with this is it's usually conservative to leave it at 1 square foot. Basically, the bigger your rafter span is or something like that, or your stud span is, there's kind of this turbulence of the wind and all that averages out. And so you can sometimes reduce your wind loads based on that. But again, the conservative thing is to leave it at 1 square foot. We're going to leave it at that for now. Next, we can see we've got our gable roof type, roof pitches 8 and 12. If I look now, I've got roof top height, and then my least horizontal dimension. Let's just go back into our presentation. And so if we've got 10-foot floor height times 2 floors, so 20 feet, and then where you've got an 8 and 12 slope, we've got about 25 foot roof height. You're probably going to want to actually calculate this. This is just an example, so we're going to leave it as is for now. And lastly, we've got our least horizontal dimension. And I think, whoops, there should have been a dimension line here. I apologize. Let's say that this is 24 feet. So the horizontal dimension here. So I'm going to type in 24 feet. Okay, and then scrolling down here, we ask you for the ground elevation. We're probably near sea level if it's a lighthouse, but if you're in the mountains, you can increase this ground elevation. The air density gets lower, and so then you can actually reduce your wind loads because the air density is lower. And similarly with the hill or escarpment, we're just going to leave this at no for now, but depending on your site conditions, that might be different. So with that, we basically designed or we found our wind loads. We can see we've got the little zone areas here, and then these correspond in this table to these zones here. And so we can see for the different zones, we've got positive wind pressure and then negative wind pressure. So negative being suction loads. So if I look here, I've got my corner zone width is 3 feet. If I've got studs at 16 inches, I might have a gable wall. I might be confident saying, studs or rafters, I might be confident saying, you know what, let's, these will be supported on their own. Let's only focus on the middle part here when we're designing these rafters. So we'll look at zones 2R, 1, and 2E, as well as zone 4 for walls later on. So if I come down here, set 2R1, so 29.2, 47.3, 2E, same thing, and 2R, same thing as well. So actually, our life's quite easy. It's 30 PSF positive wind pressure minus 47 negative wind pressure. So I'm going to go to my project defaults now and set this. So uplift wind pressure, we said, I think we said 48, and then 30 was okay here. I'm just going to double check that. 47, 48, all good. And then if I look at my wall pressures, I've also got 30 and 33. Or at the corners, I've got 31 and 39. These aren't that high of wind pressure, so we're just going to use the highest one to be conservative in this case. So 31 and 39. And I'm going to enter these down here in the default wall loads. And I'm actually just going to enter 40 and 40 here. We'll keep it safe. All good.
Hey, Laurent, quick question from Randy Katz out in Oregon.
Yeah.
Earlier, you put a 300-pound minimum live load.
Yes.
Curious why you decided on that and like what the rationale behind that number was.
That's a great question. So it really depends on jurisdictions. What I would say is look in your building code. Quite often we'll have a 300-pound minimum live load for roof loads, and that corresponds to when the workers are putting, say, the shingles on the roof. They're going to stack a bunch of shingles up there, and that's basically what that is. It's quite rare that this will actually govern in a design compared to the 20 pounds per square foot live load, but we do have that here. We'll add that just to be safe, basically, to make sure that we're following our building code.
Awesome. Appreciate it, Laurent. One last thing very quickly on the wind loads.
Yeah.
David Hordequin sent in a comment. Wondering if you could just take a second to touch on the enclosure type as well, just because it's a critical input.
That's a really good point, and my apologies, I totally skipped over that. Enclosure type. So we typically have, there's 3 types of buildings. We currently support 2 in ClearCalcs: enclosed and partially enclosed buildings. What that means is, and we can open it here, oops. If you have an enclosed building, you're basically saying that there are very few windows in your building, or that your windows are protected and they're not going to break during a big windstorm. So if a 2x4 flies in the wind and hits it, it's not going to break. Whereas a partially enclosed, you're basically saying, I've got quite a few windows, and there's equations for that in the ASCE 7 code. But if I've got so many windows, and in a big windstorm, it's probable that quite a few of them are going to break. So then I can have winds can start going into the building and kind of creating even more pressure against the walls and increasing my loads. So basically, all that to say, partially enclosed would be kind of the conservative case for a building, and it's typically what would apply for most buildings. Enclosed would be really if you kind of have a windowless box, and in that case, you are able to reduce your wind loads. I hope that kind of helps clears things up. It's a little simplified, but thanks, David, for bringing that up.
Yeah, thanks, Laurent. And one thing I do just want to quickly touch on for everybody watching, I know Laurent is running through the project defaults here because we're designing, the idea here is we're designing an entire home top to bottom. But just a friendly reminder here that if you guys do just have a beam, or you're just maybe renovating a portion of a home, remember that these project defaults are just defaults. We don't need to come in here and run through every single input. There's a possibility that every single input on this project defaults page might not apply to your specific design. But like Laurent's going over right now, It's just a time-saving tool if you do have an entire home and you want to set everything once.
Yeah, thanks for bringing that up, Connor. And really, exactly. Nobody's forcing you to use these. These are really there for you to save time if you find it useful for yourself. What I'll say is if you're not finding it useful, we'd love to find out how we can make it useful, because I think it's a pretty powerful feature, and so we'd love to be able to make it even more powerful and better for everyone that's using it. So with that, I'm going to keep going. We're going to skip ceilings here just in the interest of times, but we're going to look at the default floor loads. In this case, I could pick a bunch of different types. For instance, if I've got a hotel, or I think, if I've got a roller skating rink, that's a fun little lighthouse dwelling thing to have. Probably we're going to be looking at 1 and 2 family dwellings, and usually what we're going to have is the all other area. So that's kind of the generic 1 and 2 family dwelling load. So you can see we've got a 10 PSF floor load, dead load, and then 40 PSF live load. If, for instance, I knew that all the floors were going to be some fancy tile, I might bump this up from 10 PSF to 20 PSF or something. In this case, we'll leave it at 10. Finally, with the wall and window loads, this is where you can set the dead load of your wall. In this case, we're just going to leave it as is. But if, for instance, you had a masonry wall or something like that, that might be significantly higher. So you do want to take a look at that. And then here we entered already our wind load, so 40 PSF both ways. And I'm going to stop there for the project defaults. So with that, we basically set up everything that we need for our design. So I'm going to jump back into PowerPoint. So we've entered our loads, we've entered our floor height, and we've entered our roof pitch. So next, we're going to look at members. So the cool thing in ClearCalcs here is we have what we call presets. So just looking at the wood beam, for instance, we've got quite a few different types. So if you can have a generic beam, a generic flitch beam, floor joist, deck joist, hip rafters, whatever you can think of. The important thing here is behind the scenes, it's exactly the same calculations. All we're doing here is we're changing inputs to make it fit with kind of these typical conditions. And the default values that we use in these inputs correspond to the default values that we've set in the project defaults. So for a floor joist, we're going to use a default floor load. For a rafter, we're going to use the default roof load, for instance. One thing again, if you're not seeing something that you design often, you think it would be useful, send us a message. We'd be more than happy to look at being able to add either a preset or a new calculator so that you can get your work done faster in ClearCalcs. So just looking here, we've got here some rafters. Looks like we've got some ceiling joists, but we said we'd ignore them. We've got a wall here. Looks like this might actually be masonry, but we're going to pretend it's wood stud wall for now. And we've also got some joists here. So let's go now and just going into ClearCalcs, I'm going to look at the add new calculation. If I look at my wood beam, I've got floor joists, I've got rafters, and then I can go in my wood column. I've got my stud wall, interior or exterior. And so with that, I'm pretty confident that I'll be able to do everything I need here in ClearCalcs. Next is sizing members. So once we've identified which members we're actually designing, one of the really cool things, and we'll look at how we get to that point, is we can give you a quick kind of overview of the design parameters here. So we can filter by the different size. And if you set your preferred sections, as you can see here, you'll already see your preferred sections at the top of the list. So it makes it really easy to visualize kind of different sizes and how useful they are. And we've also got this cool feature called auto size, which I'll show you in just 1 second. So now let's design a rafter. So let's go into ClearCalcs and create a rafter calculation. Okay. And now that this is going, the one parameter that we're going to want to look at here is 12-foot plan length for our rafter here. So if I come here, I've got my beam plan length here. Right now it's at 14 feet. I'm going to change that to 12 feet. And if I see here, my incline pitch is already at 8 and 12, and I can see it's getting it from the project default. It's brings it to the top as we'd expect. Everything here is basically as I would expect. I can see I've got my 8 and 12 pitch. I've got my alternative minimum live load showing up here. And then I've also got my wind loads, snow loads, and roof loads. Now this diagram is a little confusing sometimes. Now basically what we're doing is we're taking the rafter and we're kind of moving it sideways, and then we're transforming the loads so that they're kind of, we see the loads that are aligned with the rafter and the ones that are perpendicular and then cause bending. So that's what you're seeing here. That's why, for instance, that 300-pound minimum live load is actually shown up as 250 pounds, because once the rafter is at pitch, the gravity direction kind of changes there. I've got my spacing here of my rafters. That's 16 inches. Again, that comes from my project defaults. And then I can also see I've got my distributed load. So my dead load, 15 PSF for the roof, 20 PSF roof live load, 40 PSF snow load, and I've got also my my wind loads here. So 30 PSF down, 48 PSF uplift. So with that, I am good. So I've got basically all the parameters I need to design my rafter, but I'm seeing here I'm at 59% utilization. So maybe I can save some time or some wood. So I'm going to click the select button here and open up our selector. And if I look here, I've got at the top all my different Douglas fir sizes. So right now I've got a 2x12. If I look, it looks like a 2x10 would also pass, but not a 2x8. So I could pick a 2x10 and be happy. Now, just for the sake of showing off, maybe I picked a 2x4 instead, and it's not passing. I don't want to go to the member selector and figure out which one works. I might just hit auto size. And once I do that, it basically goes through my list of preferred section, and it looks at which size is the closest to 100% governing. So we don't know the price of every piece of wood, so we can't necessarily optimize for price as of yet. But what we can look is what's the most structurally efficient. So the closest thing to 100% utilization. So that's what we're seeing here with this 2x10. All right, so next we're going to look at load linking. So biggest thing here, copy pasting numbers, you can make a lot of mistakes with that. You're spending a lot of time, especially when you start thinking about, oh, we got to make a change, and you got to think about what's affected, what's under that beam or something like that. I think we've probably all seen an error that came from that. So ClearCalcs has a really cool feature here that's called load linking. And basically you can carry your loads all the way from the top of your roof all the way down to your foundation. And it is super useful. So we're going to go right into using that. And really what I want to say is it's not just one member to the next one. It keeps going down and keeps tracking the entire way down. So it's super, super powerful in that regard. So look in here, you can see here we've just got our load path showing up. And so we're going to reproduce that in ClearCalcs. So first things first, we're going to do our ridge beam, which the rafters are sitting on. And then we're going to do the first floor stud wall. Then we're going to design some floor joists. Then we're going to do a second floor stud wall that supports the joists and the wall above it. And finally, we're going to do the wall footing. And we're going to do these kind of quick fire just so we save some time. But the idea here is really to show how all of these components can come together using the load linking. So let's jump into it. So first thing I said, and actually what I'm going to do to make our lives a little easier here, I'm going to rename this to rafters, so I remember it. And I'm now going to create a new calculation, wood beam ASD, and I said I would create a ridge beam. So putting that here. And if I look at the image here, I can see my ridge beam span is going to be 24 feet in this case. So going back here, I can change my length to 24 feet. And the other thing we'd mentioned was we're going to link our rafter loads here. So I'm actually going to delete all of these default loads. And I'm going to come here in the align loads segment. And I'm going to come here and link our rafters. Now you see there's two locations. So that's both ends of the rafter. When we're dealing with inclined member, the 0-foot location is the lower one. And then the higher location is the higher end location. So since we're at the rafter, we're going to look at the 14-foot. Now, because it's distributed loads, it actually doesn't really matter because it's the same reaction, but it's there in case you need it. And so I'm going to start location 0 feet and location L, so that this appears here, and then I can see I've got my rafter load applied to my ridge beam. Now, if I look here, I've got rafters showing up on both sides of my ridge beam. So I'm going to link them again from the other side. So if I do this, I'll just do it again quickly, 0 to L. And now I've got my 2 rafters from each side. The loads are being applied as I'd expected. So if I zoom out, ooh, I'm not doing too good, however. I'm really failing in bending. One thing I can look at here is lateral torsional buckling. So maybe I'm confident that my rafters will brace my beam. So I can perhaps switch this to perhaps a top brace if my rafters are sitting on top of there. And that helped me a little bit, but not enough. So let's come here and maybe let's try our luck with auto size. Let's see what it tells us. Nothing worked. So let's come here. Let's look at what we have. Even if we look at the micro lambs, we just almost passed with the 1 3/4 by 16. So let's try perhaps a 1 3/4 by 18. If we look, that's good. So we'll pick that one instead. So we've got 3 plies of 1 3/4 by 18 micro lambs, and now everything is passing. We're happy. Not going to spend too much time on this one. It's really just to show a quick linking here. So I'm just going to rename this to ridge beam. Going back now, we said first floor, or that should actually be second floor, stud wall. So let's go and create a stud wall. Wood column, ASD, exterior stud wall. And we're just going to let this load really quickly. And I'm going to rename this to second floor stud wall, so it's clear. And I can see by default here, I've got a 2x6 Douglas fir. I'm probably okay with this. I've got my 10-foot column height. That's set up from my project defaults already. So if I updated my column height, that would or floor height, that would automatically be updated. I can keep scrolling down. And the important thing here is, again, my loads. So I'm going to delete this default one. Again, I can see my stud spacing 16 inches coming straight from my project defaults. And what I'm going to do now is I'm going to link my gravity loads from the rafters, the other end of the rafters, on the stud wall. So I'll come here, link this, rafters. This time I'm going to use the ones at 0 feet. And here we go. So now that is linked here. And you'll notice we've already got our wind load applied on the exterior stud wall as well. I can see I've got my 40 minus 40 PSF wall wind loads. So good here. It looks like in this case, this is plenty of capacity for a stud wall. It's mostly governed just resisting the wind load, and we're still good. We're at about 30% governing. Because it's a wall, we might have some insulation in here. So we'll leave it as a 2x6. Everything is good. On to the next one. Floor joist. So let's come here and do our floor joist. And this one, I'm really not going to spend too much time in. So ASD. And going to create this one, rename it to floor joist. By default, I got a 2x10 Douglas fir number 1. Plan length is 14 feet. Maybe we'll set that at 12 feet to match the rafters here. And 56%, let's hit auto size. And turns out 2x8 is good enough. I can scroll down here and I can see the joist spacing matches what I said, 16 inches, and I've got my 10 PSF dead load, 40 PSF live load. Things are good. And next, we've got another stud wall. So that's our first floor stud wall. So wood column, exterior stud wall. And this is where it gets a little interesting, I think, is because we're now supporting quite a few things with this stud wall. So first floor stud wall. And the first thing I'm going to do now is I'm going to go straight to my loads. I'm going to delete this default load. I'm going to keep the wind load, however, and I'm going to link now my gravity loads. So on this stud wall, if I look here, I've got this wall above it. I've got my joists, and I've also got the roof rafters that are sitting on the wall above it. So important thing to note here is I'm going to link now the wall. So if I go to second floor stud wall, I'll use the lower stud, so it's 0 feet. And because I linked my rafters to my stud wall above it, to the second floor stud wall, these loads are automatically getting carried to my first floor as well. So basically I've got the rafters sitting on the stud wall above, stud wall sitting on this one, and then these loads are automatically getting carried. So if I were to change my rafter loads, it would carry down all the way to here with no problem. I'm also going to add my floor joists. So if I come here, I'm just going to pick this. I've got my 71.3 PLF dead load, 240 live load, and I can see these are applied here. And I've also added a small eccentricity to these loads, so D/6, just in case the connections or something are not properly aligned. So just to build a little bit of margin of safety. If I look here again, these loads are still pretty small on the stud. So what actually ends up governing is still the wind, and we're still at 30% capacity. So actually, we're happy with this. Things are good. We said we'd stick with a 2x6, so we're good. Going back now, last part to do here is our footing. So again, I'm going to go through this quite quickly, but I'm going to design a wall footing. And in this case, I'm going to go again straight down to the loads. I'm going to delete the default ones. And in this case, the only thing I need to worry about is going to be my second floor stud walls. And that's bearing directly on top of my footing. Coming back up now, I can see something is failing. Oh, we've got net uplift. That's a bit of an odd one. So we've got net uplift on our footing. We don't want it to go up in the air. And my apologies, sir. I think that I think I mixed up a little something here. That said, what we're going to do just to get this example going, we're just going to add a fake load, and we're going to add this at as a dead load. Maybe we'll just add, say, 500 pounds per linear foot. Okay, and that's going to keep our footing down on the ground. My apologies about that. That wasn't quite supposed to happen here, but if you ever run into this situation, you've got a little tip here about adding a fake load. So you might want to make sure that actually matches your real design.
Hey, Laurent, yeah. Just gonna interject really quick with a question from Sunny.
Sure.
So when you were linking your loads here to this footing, you linked the second floor loads. Was that on purpose there, and then just a reason for
that's what it is.
That might have been, yeah, why you're getting that uplift.
So let's try that again. First floor. If I did that. There we go. Thank you, Sunny. I think you caught my mistake there. That's why I was so confused. My apologies. Thank you, Sunny, for bringing it up. I think now that makes a lot more sense. So we've got stuff on our footing. Just looking quickly, it looks like we're passing again by a lot. We've got low bearing stress, low shear. So we might even be able, if we wanted to, we could say remove the transverse reinforcement and design this as a plain concrete footing. And I might be able to reduce my width here to 3 feet or something like that. And we're still good. I'm just going to leave it here for now, but you can see, so I can design my footing quite quickly. And it's going to take all the loads here from the stud wall, which, because I've linked everything above it into this calculation, all the loads from my rafters, my stud wall above it, the floor joists, it's all coming into this calculation through this single link. So quite a useful feature, I think, here, and it basically guarantees you that if you say, let's try it together right now. If I went all the way back to my rafters, and for some reason I want to add a, let's say, a fake chimney right in the middle of a rafter, I can do L/2, and then chimney L/2, and then say I've got a 400-pound dead load. you can see the little gear symbols here. Now it's failing this rafter. We'll ignore that. But all the little gear symbols here tell me it's recalculating these things based on this new load. And so it takes a minute because it's recalculating literally everything. But if I go down to my footing now, we'll see that we've got that little blue bar, so it's calculating quickly. Okay, we'll stop here for now, but as you can see, it's calculating. We'll come back to it in a second. Last part here is going to be, we've done our design, let's export it. So if you're ready to submit your work, we have 3 different modes of printing in ClearCalcs. We've got the kind of the one-pager, the standard mode, or then a detailed mode. One page is, as it says, every calculation is going to take 1 page. Standard mode is basically the same inputs that you see when you're entering them in ClearCalcs, and the same kind of little summary descriptions will show up in that one. So that's typically, 3 or 4 pages, depending on the calculator. And then detailed mode is literally every single calculation that ClearCalcs does. Behind the scenes, everything is just in there and it's printed. So to be honest, it might not be surprising to see like a 10, 15, 20 pages for one calculation, because we really go that much in depth with every single calculation. We always kind of joke that if you've got a tough client and you want to justify your fees or something, and you want to just give them a big stack of paper, detailed mode is for you. You can give them that big stack of paper. Other thing too, when you've got your project details, that's going to set up your project number, your client, all these kinds of things. So you'll see those in a second when we export this project. And finally, a cool thing you can do here is when you're done, you can hit archive on your project, and I'll show you how we do that. And basically that kind of locks your project as is. You'll export the PDFs, and then if you wanted to kind of come back and edit it, you would be able to duplicate and create a new project to do it. So it's kind of a cool way to make sure that all the work that you've done in a specific building, once it's closed, it's not going to get changed ever again. It's locked in place. You've got your PDFs. And then if you did want, however, to go back and change something, you can create a duplicate. So you've got now 2 copies of your project at different points in time. So going back to ClearCalcs, we can see now that everything's solved. The loads here on this footing have updated. And for instance, my bearing stress went up a little bit, and I can see also that my ridge beam is no longer passing. So if I was, if I kept going here, I would go back and redesign my rafters and my ridge beam based on this new chimney addition, or whichever one we did. So anyways, back to exporting. I'm going to click here, this export button on the left. I'm going to click this, and then I've got my different calculators here. So I'm going to select all. If, for instance, I decide, I don't want to show my ridge beam in the end because we're not using a ridge after all, no problem. I can uncheck it. It's not going to get exported. That's fine. I'm going to select one-page summary. I think that's usually the most convenient one. And I'm going to hit export. Now it's warning me that 2 of these are failing. That's fine in this case. So it's going to export. Once that's done, and you'll see that this part does take a little bit of time. The reason it's doing that is when we export, we basically recalculate every number just to make sure that everything's passing one last time, that you didn't have, say, a hiccup with your internet connection or something like that. So it's just a last kind of safety check that we do. In the meantime, you can check out how to do load linking, auto size, and project defaults. We've got some articles as well that might help you, although we've discussed a lot of that today. So we can see now that this is done. And Mr. Lightkeeper, if I open this, I'll see I've got my file. I've got a summary of the different calculations I've made. So you can see here the different members, quantities as well. If I scroll down, I've got a summary of my project defaults as well, including my default loads. And then I've got my wind load calculation. I've got my report with the graph, and then just page per page, it's going to be the different components that we designed. So we're all done. I can now go to project details. If I'm completely done, I can just hit that box here, archive Lightkeeper's dwelling, archive, and that's it, it's archived. So now if I wanted to edit it, I can see the PDF, they'll show up in a minute or two, but if I wanted to edit it, there's the copy button right here. So I can duplicate it, and that's gonna take a second as well, but then once that's done, I'll be able to edit the project again. but I'll know that I've got kind of my locked in copy from my previous project, still saved, still with the PDFs and everything. So that's kind of a comfort thing, and then I can do my modifications here as I wish. Okay, so with that, oh yes, we have that little picture here. We've got some happy engineer or architect at some point who put their stamp on there, and everybody's happy. We've got a new dwelling for our Lightkeeper. And with that, I think I'll stop it here. If you've got any questions, or if Connor, if you think I missed something you'd like to add, now's the time. I really appreciate all of you listening to our webinar. I hope this was useful. And yeah, more than happy to take any questions you have at this point.
Yeah, thank you, Laurent. One question that I didn't get a chance to ask from James Baker. James, thanks for asking this. He was curious if there was a way they could enter the soil bearing capacity of the soil when you're on the foundation calculator, the spread footing that you were doing.
Certainly, that's a really good point. So if we go back to our footing, yes, by default, we've got here 1500 PSF allowable capacity. That's really low. It's usually conservative. In some areas, you might be lucky and have up to, say, 5000 PSF. So you would be able to enter this. And if you look at my bearing check here, it's gone down significantly. You can also say check your unit weight of soil as well as your coefficient of friction here.
Perfect. Thank you, Laurent.
Question.
Yeah, and very quickly from David Hordequin again, so he was just curious if you could show and just reiterate where that copy or duplicate icon was. I'd say both on the sheet level and then on the project level.
Absolutely. So if we look here, I've got this button on the top right. I'm going to zoom in here. The copy right next to the archive button or the delete button. Try not to hit that one if you don't want to, but the copy button is right here. So that's what it's here for. And if I went into my project, so back to projects, and I click here, I can already see I've got the duplicate button here. I've also got the archive button. And then I can also click include archived projects, and you'll see here my archive project is showing up now. So if I click on that, it's now archived. I can't do anything with it except download the PDFs or create a copy at the top right. Hope that cleared things up, David. That we lost Connor.
I had myself muted, my bad.
Oh.
Didn't want you guys to hear my heavy breathing here. I'm getting quite a few questions coming through regarding just reviewing this webinar, making sure everybody will be able to have a recording of it. Yes, we are recording all of these webinars. You can find them on our website. We will send out, everybody that's here today will receive an email with this recording once it's uploaded. Typically that'll take a day or two. So just to kind of reiterate to everybody that's joining in here, we will send this out and you will have the ability to watch it back. All right, so we have a few more questions here.
Sweet.
So George actually had a great question here. So going back to the wind loads, and I think wind loads is something that I know personally on demos, I get quite a few questions on. So are they able to have yet in ClearCalcs a wind load report that includes the negative and positive wind pressure on, say, windows and doors?
That's a great question. So the short answer is kind of a yes and no, unfortunately. The best reference I can give you here, if you keep it at the 1 foot squared effective areas, you can then look at the pressures here in the different zones, match them to kind of this picture here. So if you've got a window in zone 5, for instance, in the corner, you might have a higher wind load than zone 4, and then basically multiply that by the area of that window or that door. Very conscious that that's not necessarily the most kind of convenient way to do things right now. If you've got to multiply these things manually. What I'd ask is, if you don't mind, send us an email with kind of how you would typically do this for opening pressures, and we'd be more than happy to take a look at how we can how we can do this better in ClearCalcs.
Yes, thank you, Laurent, and great question, George. We have a couple other questions. I do want to reiterate, if we don't get to them, we will send through responses to you guys. One thing I do wanted to point out, just while I have everybody on the call, just with a couple more minutes, want to make sure we don't miss this opportunity, because we haven't yet set out a what's new email to everybody, but Laurent's had the North American engineering team kind of on a roll, humming along and pushing out a ton of new features and calculators. Since our last webinar, we have released 6 new features specifically for the US standards. So just for everybody on the call, wanted to make sure you guys were aware. I'll just quickly run down these and then expect an email from Addie or our marketing department as well. So we are now doing tension checks in wood columns. What Laurent's bringing up here, something that's been requested quite a bit. You now have the ability to do hip and valley calculations with different sized roofs or different ends, so not just a perfect square. You can actually start to look at more of a rectangle. You can now, when you're designing an I-joist in our beam calculator, we can start to have 2 plies, so we're no longer limited to the 1 tie in the I-joist. Sorry, Laurent, I'm going quick here.
All good.
Another one here, I know Laurent touched on the spread footing during today's webinar, but previously you could only do steel or column or generic, or steel or concrete or generic column types. You now have the specific ability to do wood columns on top of a spread footing. Something that we're extremely excited about. I know it's getting more and more popular in the States with the price of wood, but cold form steel, we have massively increased the capability of this one to now offer boxed and back-to-back sections. And for everybody listening, I'll summarize this once I'm done going through the list. And then finally, I know a majority of the people on this call, who I know I've talked to at least, do a lot of wood. But for those of you that do steel, we are also now setting the default yield strength in US steel. So quick summary there as I ran through that pretty fast. Again, we'll be sending out kind of a what's new email. There's just a lot to touch on just because Laurent's got the team rolling. So we're doing tension checks in wood columns for US. You can now do hip and valley rafters with unequal roof slopes. You could do 2 plies for I-joists. The wood column option is now available in the spread footing calculator. You can now do boxed back-to-back sections for cold form steel. And we're now looking at, as Laurent just showed, we'll set the default yield strength in US steel.
Yes, you can see real. Thanks, Connor. I was trying to keep up as you were saying them.
Sorry about that. I was trying to get done in time. I know everybody's busy.
Yep, all good. And then the yield strength you can see here for the angle, it was at 50 KSI for an I-beam and now 36 for an angle section here. So just to show you, it changes when you pick them, so you don't have to do that manually anymore.
Perfect. Thank you, Laurent. Thank you. Sorry for going quick there. And sorry for anybody if I ran through quick there on those new updates. Like I mentioned, expect an email. Check those out when you're in the platform, start to test them out. And as always, like I mentioned, Laurent's got the team rolling in North America. We're adding to our team. We're getting more efficient. We have more capability, more time, more human power as well. So send through your suggestions. We'd love to be able to just knock those off the priority list to make sure you guys have every single thing you need in ClearCalcs. And then, sake of time here, just because we have less than a minute left, everybody that I haven't brought up your question, I apologize. We didn't get an answer live on this demo, but Laurent and I will meet Friday this week, Thursday or Friday, and run through all of these, make sure we send you guys answers. And so that way you guys have everything you need in ClearCalcs. As always, use that help button that you're seeing in the bottom right-hand corner of Laurent's screen. Click that help button. If you want to reach our engineering team or myself directly, click ask in that pop-up and you could send us a question, send us a help request. You could even say hello, ask us how our weekend was. Thanks again, Laurent, for running through that. For everybody's reference, I believe our next webinar will be around cold form steel, but if you have any suggestions on topics you'd like us to cover, let us know. Thank you, everybody, again for joining. Thank you, Laurent, for sharing your expertise.
Thanks,
and I
guys.
hope
Thanks,
everybody
everyone.
has a great day. Thank you, guys.
Thank you.